Hi, Megan. What a cool question this is that you sent me. Basically, it's asking us that we have a situation where we have a population proportion of 0.55, and it has a margin of error of 2%. And I'm thinking that you're pretty comfortable with coming up with the confidence interval. I think that's pretty easy to do. But then when it asks us about the size of the sample for this poll, I think what's different and the reason that it's going to take us in a different direction is it's not just saying what's the sample size needed for the error, it's actually saying what was the sample size needed for this particular poll. And you're right, here is that description in here, and it's taking this formula, which came right off of the formula sheet, which E is approximately equal to 2 times p hat times 1 minus p hat all over n. So if you start with that particular equation, and this is if we want to find the error, and of course we already know that our p hat here is 0.55. We don't know what n is, but we do know that our margin of error is equal to 0.02. And so what they show is that to find the appropriate n for this particular poll, you want to work backwards using this formula. So the way that I would do it is I would start by, I want to solve for n. And so the big problem, of course, is let's get rid of that square root sign. So if we square both sides, we're going to get an e squared over here, right? And over here we're going to get 2 squared is 4. There's the 4 we talked about. And then everything inside of the square root is just going to become, the square of a square root is itself. So we'll get p hat times 1 minus p hat all over n. Okay. Now remember, our goal here is that we want to get n by itself. So the best way to do that is to multiply both sides by n. Multiply this side by n, multiply this side by n. These will cancel, and you're going to have n, let's say e squared n, is equal to 4 times p hat times 1 minus p hat, right? And then the final step to isolate our n is going to be to move this up a little bit, move it down a little bit. Let's see. Gosh darn it. There we go. Our final step is going to be to divide both sides by e squared. So if I divide both sides by e squared, divide this side by e squared, divide this side by e squared, I'm going to get n is equal to this, 4 p hat times 1 minus p hat all over e squared, right? Squared. Let's just go back to here, which is exactly what they're showing they have in this question. And then you're just plugging the numbers in. But I think what makes this problem interesting and a little bit different, because I think you and I, or at least I was saying, why would we not have, where's my board again? Why would we not have, why wouldn't we use the formula n is equal to 1 over e squared? Because if we do that, we're just going to have 1 over 0.02 squared, which is going to give us 2,500, which is not the answer, which would be frustrating for both of us. Why is that not the answer? And so this is the answer if you want to achieve an error, a margin of error of 2%. What size must your sample be? Okay, that's the answer to that question. But that isn't what this problem asks for. It's saying I've already given you a problem. What was the sample size? And so that's a little bit different. Hope this helps you, Megan. That was a great question. Keep asking them.